Hello everyone. Today we're going to be learning about lines of best fit and also the least squares method. So from the syllabus you'll see that what we're going to be required to do is to be able to fit a line of best fit by eye using digital technology and also a least squares regression line using digital technology. Okay. Also importantly, you need to know the rules of how to calculate the gradient and the y-intercept when using this method, because often they will just give you pieces of data and you'll have to figure it out, and they may not give you all the scores. So it's important that you know those rules, as they may or may not be given to you with the question. It's not on the formula sheet. So first off, what is a line of fit? Well, a line of fit shows you where most or all of the points are aligned as closely as possible. You want the line of fit to go through as many points as you can, keeping roughly the same amount of points above and below, and drawn out so the distance of the point are small as possible. Least squares method, this is probably the new bit. This is looking at a special kind of line using a least squares method where it represents all the data points. So we've got these special rules here. In this method, we'll be using the gradient, the y-intercept, as well as the correlation coefficient, which we learned how to calculate last time, and the means and standard deviations of both x and y values. Okay, so we are going to be looking at our good old friend here, y equals mx plus c. But when you're working out gradient this time, it's not rise over run or just difference in y's over difference in x. This time, it is the correlation coefficient multiplied by the standard deviation of y values divided by the standard deviation of x values. Okay, and sometimes that we give into the question, sometimes you have to work it out in your calculator. The b or the c in our case is the constant, the y-intercept, and it can be calculated using the mean of the y-scores minus the gradient times the mean of the x-scores, okay, and that can look like this. So in our first example here, I've drawn in the line of best fit already, just to make it a bit easier. But you can see here there was a scatter plot given to you, and what I did was I made my line go through the y-axis because it should have a y-intercept, and there is sort of 3 points above and 3 points below, and I've got 2 points going through my line of best fit. Okay, so that's kind of what you want to do for something like that. So just as a reminder, if we're thinking about line of best fit, then just remember it's a straight line that approximates a linear relationship between points. We're still using y equals mx plus c. Sometimes the line will be easy enough to use rise over run. Other times you'll need to use the least squares regression method. Okay, so in this example here, they gave you the graph. You can see again there's approximately the same number of points above and below, and it goes through a couple of points. There's a point up here as well. You can see where it's cutting the y-axis at 6. So when you pick 2 points and you do your rise over run, so if you were to make a triangle here, or if you make a really big triangle, which is what I think they've done, and they've done 6 over 3, but it's negative, so the gradient's -2. C or B, the y-intercept is 6, and you've got your equation of your line. Okay. What we need to move on to in Year 12 is a little bit more tricky, and it's called the method of least squares. This is a special type of line of best fit that minimizes the sum of squares of the vertical distances, or something called residuals. Okay. Now, rather than getting too complex with that, because you won't actually be asked to graph that by hand, you'll be using your calculator to work out the values and then figuring out the line. Okay. So what you do need to know how to do is you do need to know how to connect all of these rules. Okay. So we're going to be looking at y equals mx plus c, or y equals mx plus b, to get the equation of our line, this. But to do that, we are going to be needing to work out gradient a different way, using r, our correlation coefficient, and s of y, standard deviation of the y-scores, divided by the standard deviation of the x-scores. The b or c value, which is the y-intercept or the constant, just the number, that's going to be calculated doing the average of the y values minus the gradient that you just worked out back here multiplied by the average of the x-scores. Okay, and it explains that there to you there. So we might come back to this example a little later because I want to show you one we've been doing in our booklet. In our second example in our booklet, we've got a sort of more HSC style question. So it says a bus company charges its fares according to the number of sections travelled. The fare for the same number of sections may be different for different routes. Makes sense. If you catch a different bus, even though you're having a certain distance, it may cost more or less. And it says here's a table that shows the different fares. First step is they want you to make a scatter plot and draw a line of fit by using the least squares regression. Now, you're not actually going to be required to do that as such, but we're going to kind of do B first and then use it to do A. Okay, so what I did was I looked at these. Now remember, your sections would be kind of like the X and your fare would kind of be like the Y. So I put the sections down the bottom here on my graph, going from 0 to 16 because I had numbers from 1 to 16. And then my fares, you can see they start from $3 and they go all the way up to $9. So I've gone up by $1.50s, but you could choose what you want. And then I've just plotted the points on there. Okay, so I'll just zoom out for a second. But basically you can see here, for example, in my table for one, I'm at $4 and I have two of those, but I only graphed it once. Because if I graphed on top of that, it would still look red. I could do a different color. And then at 3, I was at $4.20. So here at 3 in the middle, I went up to $4.20 and I did that. Okay, and you can see what the scatter plot looks like. Kind of a little weird point here, but the rest, it's mostly a positive linear correlation, and it's a pretty strong correlation. Okay, so just to remind you, we're thinking about this here. Now, the good news is we are only required to do this using digital technology, not by hand. So when it says draw a line of best fit, well, we're going to kind of cheat a little bit and do part B first, okay? And for this section, what we're going to do is we're going to, again, get into stat mode. So mode 3, 2, you want to have your frequency switched on. And then we're going to put in our sections and fares into here. So I'm going to put 1, and I'm going to put in the values as I go just so I don't forget. And I know that was $4, but I've actually got that showing up 2 times. It has a frequency of 2 because it appears 2 in my table. So that's important that you put that in. The next one was $3. I'm going to do it in ascending order. And at, 3 sections, it's $4.20. So I'm just going to put 4.2 in there. For 5, the value is $5.20. So I'm going to put 5.2. And I'm going to go and do all of them, but just to save time, I'm going to pause and come back. All right, so I've put all of my data in, and then remember we clear the screen. Okay, once we've cleared the screen, we press Shift, we press 1, and we hit number 5 for regression line. This is where we were before. R stands for correlation coefficient. Now, just as a reminder, A is the y-intercept, and B is the gradient. Okay, so just remember A is C, and B is M. Okay, and that's going to help us get our equation. So let's get our values. So what we're going to do to start off is we're going to press 1 and get our y-intercept. So we're going to press 1, which is the A equals, and we've got our y-intercept of 3.6. So I'm going to write down over here that C is 3.6. And I also need to get my gradient, which was the B value on the calculator, remember? So I'm going to go back to here, got to clear it, press Shift 1 again, regression 5, and this time I want to hit 2 for B. And this is going to give me my this is going to be my gradient, which is 0.3. So in other words, now that I've got my y-intercept and my gradient, I can get the equation really easily. But keep in mind, they want me to use F and S, not X and Y. So I'm going to have F equals MS plus C. Okay. So in this one, my gradient is going to be 0.3. Well, I'm going to write that as 3/10 m plus 3.6. Okay, and I could convert that to a fraction as well. The only reason why I'm doing that for gradient is to help me actually graph the line. Okay, so in this case here now, what I want to do is I want to graph my y-intercept, which is going to be at 3.6. Now 3.6 is approximately here. So that's my y-intercept. Then I've got to go across, I've got to go up 3 from there. So if I do 3.6 plus 3, that's going to give me 6.6. So I've got to go up to 6.6, which is about here. And then I've got to go across 10 to the right. Okay, so from 6.6, I'm going 10 to the right, which is approximately 10's here. And 6.6 is approximately there. So that's going to be my second point. And you can see then that I'm going to do a line through that point. Okay, and approximately you want to have sort of above and below. So hopefully you can see there that we can use our calculator after typing the data in by pressing number 5 regression to get our y-intercept and our gradient. Use that to work backwards to get your line. It then says explain the meaning of the vertical intercept and the gradient of the line in this context. Okay, so in other words, they're asking you, what does the y-intercept actually mean if we're talking about fares and sections for this bus route? And what does the gradient of the line mean in this context? Okay, so what is this thing out the front here actually mean in terms of this equation? Sorry, that should have been an S there. Okay, so I want you to have a think about those ones yourself. Maybe talk to the person next to you about what it could be. Okay, questions 3 and 4, you need to again use your calculator to help you with that one. So this one's a bit more tricky, and you'd have to kind of work backwards to put in all the data. It's going to take you quite a long time, too much time for this video. Have a go at it. See if you can work backwards to type in the data. It does give you some information here about what the correlation coefficient is. So if I were you, I'd probably just estimate all the data and then check that you got something around 0.9 and explain the meaning of the gradient of the line. They want you to put the line in. And they've asked you to calculate the correlation coefficient, see if infant mortality would continue to increase, and justify your answer. Here's another sort of HSC type question where we're looking at life expectancy in different countries and the share of income going to the least well off. They want you to describe the correlation. So just by looking at it, estimate the correlation coefficient, and then create a least squares regression line with the equation, put it in, calculate the correlation coefficient, and see what the meaning of the value obtained for the gradient is. Okay, so keeping that in mind, I'd like you to have a go at 6D. Now there are some questions in 6D that are a little bit different to what I've showed you, particularly these sorts of ones here, but you're just substituting into the rule that I showed you. So if you have a read through the examples in your text, sometimes they ask you to work out the gradient using this method here, where you would have to use values that they've given to you. So they've actually got them worked out here, like the standard deviations. You just sub them in and multiply it by the correlation coefficient. Then the y-intercept using, again, that formula, which was shown to you before. And then they get you to sub it into y equals mx plus c and graph it. Okay, so in our course, you don't have to calculate it by hand, but you need to know how to obviously graph the line at the end. Here's a second example where you're combining a last lesson's work with this lesson's work and talking about associations. So have a read through the examples and then have a go at some of the questions in 6D. And I'm really looking forward to seeing you guys soon.